Welcome to the soothing cosmos, where the wonders of the universe unfold in calm and captivating detail. Here, we journey beyond our world, exploring the mysteries of space, the beauty of distant planets, and the secrets written in the stars. If you enjoy traveling through the cosmos with us, remember to subscribe and join our voyage across the universe. The major asteroids of the solar system: Ceres, Vesta, and Pallas. Amidst the vast expanse of the asteroid belt, located between the orbits of Mars and Jupiter, lies a collection of rocky worlds that offer a glimpse into the early solar system. Among these, 3 asteroids stand out due to their size, composition, and scientific significance: Ceres, Vesta, and Pallas. These celestial bodies are remnants from the primordial disk of material that never coalesced into a full-fledged planet, providing valuable insights into planetary formation, chemical composition, and the history of our solar system. Ceres, the largest of the 3, holds the distinction of being a dwarf planet, while Vesta and Pallas are among the most massive and well-studied asteroids. Studying these objects allows scientists to better understand the processes that shaped both terrestrial planets and smaller bodies, offering a natural laboratory for exploring planetary evolution, geology, and the potential for water in the early solar system. Ceres. Ceres, discovered in 1801 by Giuseppe Piazzi, is the largest object in the asteroid belt with a diameter of approximately 940 kilometers. It comprises about 40% water ice by mass, mixed with rocky material, and has a relatively low density of 2.16 grams per cubic centimeter. Its spherical shape distinguishes it from most other asteroids, which tend to be irregular in form, earning it the classification of a dwarf planet. Vesta. Vesta, discovered in 1807 by Heinrich Wilhelm Olbers, is the second largest asteroid in the belt, with a diameter of about 525 kilometers. Unlike Ceres, Vesta has a more irregular, slightly ellipsoidal shape and a rocky, basaltic surface, indicating a history of volcanic activity and differentiation. Its density of roughly 3.42 grams per cubic centimeter suggests a composition rich in silicate rocks and metals, making it one of the most geologically complex asteroids known. Pallas. Pallas, discovered in 1802 by Heinrich Wilhelm Olbers, is the third largest asteroid in the belt, with a diameter of around 512 kilometers. Its highly inclined orbit distinguishes it from most main belt asteroids, taking it on a unique path that intersects with the orbital planes of other bodies. Pallas has a density of 2.77 grams per cubic centimeter and is composed primarily of silicate rock, offering clues about early solar system differentiation and collisional history. Ceres. Ceres' surface is a mixture of clay, carbonates, and ice, with occasional bright spots, such as those in the Acator crater, which are deposits of sodium carbonate. Observations from the Dawn spacecraft have revealed a geologically diverse world, with evidence of cryovolcanism, volcanoes that erupt water or brine instead of lava. This indicates that Ceres may have had, and possibly still has, subsurface liquid reservoirs. Vesta. Vesta's surface is dominated by basaltic rock, shaped by extensive impact craters and large basins. The Rhea Silvia crater, which spans nearly 500 kilometers, is one of the largest impact structures in the solar system and has exposed Vesta's deep crust and mantle. These geological features reveal a history of differentiation, where heavy elements sank to form a core, while lighter materials formed the crust. Pallas. Pallas has a heavily cratered and uneven surface, with regions of high elevation and steep ridges. Its composition, primarily silicate minerals with some metal content, suggests it is a remnant protoplanet that never fully differentiated. Observations indicate a surface shaped by collisions and past thermal processes, providing a snapshot of early solar system dynamics. Ceres, Vesta, and Pallas each follow distinct orbits within the asteroid belt. Ceres moves in a nearly circular orbit at an average distance of 2.77 astronomical units, AU, from the Sun, completing one orbit roughly every 4.6 Earth years. Vesta orbits at $2.36 with a period of 3.6 Earth years, while Pallas has a highly inclined orbit at about $2.77, completing an orbit in 4.6 Earth years. These orbital differences, combined with their masses, influence the gravitational dynamics of the asteroid belt, creating regions of stability and gaps, such as the Kirkwood gaps, shaped by Jupiter's gravitational perturbations. Ceres and Vesta have been studied in detail by NASA's Dawn spacecraft, which orbited both bodies between 2011 and 2018. Dawn provided high-resolution images, compositional maps, and measurements of gravity, revealing the internal structures and surface compositions of both asteroids. Ceres was found to possess signs of water ice, cryovolcanism, and potential subsurface brines, while Vesta's basaltic surface confirmed its differentiated structure and impact history. Pallas, while not visited by spacecraft, has been studied extensively using ground-based telescopes and adaptive optics. Observations have allowed scientists to map its surface features, determine its shape and density, and understand its unusual orbital inclination. Ceres, Vesta, and Pallas have played important roles in the history of astronomy. As the first asteroids discovered in the early 19th century, they challenged astronomers' understanding of the solar system's architecture. Ceres, in particular, was initially classified as a planet before being reclassified as an asteroid, and eventually a dwarf planet, highlighting the evolving nature of planetary definitions. Scientifically, these asteroids offer windows into the processes of planetary formation, differentiation, and collisional evolution. Their varied compositions, ranging from icy Ceres to rocky Vesta, illustrate the diversity of materials in the early solar system and provide benchmarks for studying other small bodies, meteorites, and potential sources of water and organics on Earth. Future missions to the asteroid belt aim to continue unraveling the mysteries of these primordial bodies. Concepts include sample return missions to Ceres or Pallas, as well as orbiters or landers for Vesta, to study their surfaces and interiors in greater detail. Observations from Earth-based telescopes and upcoming space telescopes will continue to refine our understanding of their composition, surface geology, and potential for hosting water or organic materials. Ceres, Vesta, and Pallas remain among the most fascinating objects in the solar system. As remnants of the early solar system, they serve as time capsules, preserving clues about the processes that shaped planets and smaller bodies alike. From Ceres' icy plains and bright spots to Vesta's basaltic crust and massive impact basins, and Pallas' unique orbit and rugged terrain, these asteroids provide invaluable insights into planetary formation, evolution, and the dynamic environment of the asteroid belt. As exploration continues, these minor worlds will undoubtedly reveal even more about the origins and complexity of our cosmic neighborhood.